Students, this is the help video for the Review Unit 5 Take-Home Practice Quiz. You will be doing this on Alex during class time. This is just a help video to re-explain the concepts, realizing there's problems on this PDF that may or may not be on the actual assessment. So taking a look below, you see we have ourselves a 30, 60, 90, short leg root 3, short leg times 2. For this one, 45, 45, 90, leg, root 2. So taking a look here, our short leg is 6. That would make this long leg times root 3 would be 6 root 3. And times by 2 this way, if you had to, would be 12. This one reads like this. Something times root 2 is 5. Something times root 2 is 5. Now we know we need a root 2 here. But root 2 times root 2 gets you 2. We need to divide by 2. That'll get you down to 1. What times 1 is 5? The correct answer is 5. So the complete answer here would be 5 root 2 over 2. Taking a look at these examples. 45, 45, 90, leg, root 2. This one, 30, 60, 90, short leg, root 3, short leg times 2. So this one reads, something times root 2 is 4. Something times root 2 is 4. Our something would be 2 root 2. Because root 2 times root 2 would give us 2. 2 times 2 is 4. Correct answer here is 2 root 2. If we start here with 2, something times root 3, this will be 2 root 3, and this will be 4. Now, some of you may get this in a 30, 60, 90. Let's say this was a 6, and it would read like this. Something times root 3 is 6. Correct answer there is going to be 2 root 3. Because 2 root 3 times root 3 is 6. And then the really awkward one is when it's not divisible by root 3. For example, like a 5. And it would read like this. Something times root 3 is 5. In that case, root 3 gets you 3. Divide by 3 gets you 1. Times 5 gets you 5. That would read 5 root 3 over 3. Says solve for the right triangle. It's going to want 3 things. It's going to want this angle. It's going to want this side. And it's going to want the other side. So in this particular one, to solve for the angle, that's easy. That's simply going to be 90 minus 47. Because I already have a 90 degree here. So that gets you your angle, 43 degrees. Now you have to choose the angle you're going to work with. I'm going to work with our original angle, 47. So that is going to give this as your opposite, this as your adjacent, and this as your hypo. If we're going to go for A, that's an AH combo. That gets us ka. So that would be cosine 47 degrees over 1 equals adjacent, which is going to be that variable a, over hypo, which is 18. Cross multiply. Cosine 47, keep parentheses around that, times 18 equals a. You put that in the Alex calculator and then rounds to the tenths place. To get b, that's an opposite and a hypo, OH. That goes with sine. So it would be sine of theta over 1. Opposite over hypo. Sine 47 over 1 equals opposite, which would be b over hypo, which is 18. Cross multiply. Sine 47 times 18 would equal b. Use the Alex calculator. This one is the exact same thing. Here, you're going to be finding an angle. Finding an angle. When you're trying to find an angle, you use inverse SOHCAHTOA. Inverse SOHCAHTOA looks like this. Inverse sine. Opposite over hypo gives you your angle theta. Inverse cosine, adjacent over hypo, gives you your angle theta. Inverse tangent, opposite over adjacent, gives you your angle theta. So looking at something like this, from that angle x, this would be the opposite, this would be the hypo. That's an OH combo. So you're going to use inverse sine, opposite 10 over your hypo 12. And it wants you to round to the nearest tenth of a degree. So in your Alex calculator, you're going to do this, but I'm going to show you what it looks like on this calculator. Oh, they don't have the backwards calculator, but you'll see this quite obviously on the Alex calculator. It's pretty easy to spot. Once again, how would you solve for this angle? Right here, this would be adjacent and hypo. So this one would be inverse cosine. Adjacent over hypo gives you your angle, rounding to the 10th degree. That's inverse cosine, 7 over 16 gets you your angle theta. This is a tricky one. These are called combinations. And for this one, the most common thing is someone in a seat looking at a movie theater like this, going this way, trying to find the angle of the screen. And they give you these degrees, and they want you to find the blue and the green. And for that one, you would be adding, red plus blue. You'd be adding the red plus the blue. In this scenario, the question is, if the hot air balloon goes from here and goes up, what is this difference? That's what this question is asking. It says right here, how much higher is the balloon on the right than the balloon on the left? So the ultimate goal is the yellow. And to get the yellow, you're going to be finding the difference of this compared to this. Now, it says, do not round any intermediate computations. So you're going to write all of this down, and you're going to be working on your ALEKS calculator. So you want to figure out each of these, and you're going to put it all in your calculator at one fell swoop. So looking here on the left-hand side, if I were to solve for the blue there, the blue, that would be adjacent, that would be hypo. So I would do cosine 23 degrees equals my adjacent, which would be unknown, I'm going to call it x, over my hypo, which is 365. Cross multiply. So to get my x, I'm going to need to do cosine 23 times 365. Keep that in mind. Coming up here for this one, again, that's adjacent. Here's hypo. If I want to find that adjacent, we'll call it y. That would be cosine 41 equals adjacent, which we don't know, over this, cross multiply. Cosine 41 times 1035. That gets me y. Now to get the yellow, we have to subtract these two, which would be the red. So our yellow is going to equal the red, which would be cosine 41 times 1035 minus, and when you put this in ALEK, you have to put this in brackets, cosine 23 over 1, excuse me, not over 1, excuse me, we already figured that out, times 365. So that's in brackets, that's in brackets. So you're going to be putting this entire expression, and you're going to use the ALEKS calculator to do this. That's one style. Now the movie theater one, they're going to give you these angles here, and this would be the opposite for both of them, and they're going to give you the adjacent. So just give you a heads up, if you're getting the movie theater one, you're going to be using tangent for both of these because you're dealing with O and A, which is TOA.